Is space part of the system? We've been trying to understand how galaxies form, stabilize, and evolve. So far, we've looked at mass and gravity and explored ideas like dark matter or changes to how gravity behaves. Each of these approaches tries to explain why galaxies don't fly apart. But they all share the same basic assumption, where space is treated as the background where everything happens. A kind of empty stage where matter and forces play out. But what if that assumption is incomplete? What if space is not just a backdrop, but part of the system itself? What space already does? In modern physics, space is not just empty. It already plays several roles in how we describe the universe. It defines distance, gives things a location, and sets the geometry of how things are arranged. It carries fields, allows waves and signals to move, and responds to mass through curvature. It also sets limits, like how fast information can travel, and defines which events can influence each other. So space is already doing a lot of work in our models, but we rarely stop and treat it as a system on its own. The information gap. If space is involved in all of these processes, then it may be more than just a passive container. It may have structure, limits, or interactions that we are not fully accounting for. And if that's the case, then something important may be missing from our models. We may be throwing away information by not modeling space explicitly. So instead of treating space as a backdrop, we can begin to ask new questions. What is space made of, and how can we start to model it? A different way to model it. In Darwin's Machines, 2024, I explore a different way to think about complex systems. Instead of treating them as simple equations, we can model them as information systems that store, process, and transmit information. In that kind of model, anything that carries or constrains activity becomes part of the system. It has structure, limits, and interactions that influence how outcomes emerge. So if space plays a role in how signals move and how interactions occur, we can begin to model space as part of the system, not just the background. Where to start? As a first step, we can ask a simple question. Can a structured model of space reproduce behaviors we already observe? For example, gravity follows a very specific pattern. Its strength drops off with the square of the distance. In Darwin's Machines, 2024, I show that simple network models can naturally produce similar patterns. This happens when information spreads through local connections. This doesn't tell us exactly what space is, but it suggests that modeling space as a structured system may be a useful step forward. It can help us make connections that we haven't considered before. Expanding the galaxy model. So far, we've been trying to explain galaxies by adjusting mass and gravity. But those forces act across space, and space is already playing multiple roles in how these systems behave. If we want to understand how galaxies form, stabilize, and evolve, we may need to expand the model to include space itself as part of the system. This is a difficult problem, and much of it may need to be explored indirectly. In the next part, we'll take a closer look at the signals that move through space and how they shape the behavior of these large-scale systems.